Hello Algebra 1 students, this is Mr. Wilsey, and in this video we're going to be looking at the objective on the Pythagorean Theorem. Now I gave you the Pythagorean Theorem up here, a squared plus b squared equals c squared, where a and b represent the lengths of two sides of a triangle, and c represents the length of the hypotenuse, which is the longest side of a right triangle, and it's also the side that is across from the right angle. Okay? So let's look at number 8 here. What is the length of the missing side in the right triangle below? So we're given one length, 8, we're given the length of the hypotenuse, 17, and we're asked for this length right here. Now, the key to getting this question right is recognizing that this length here is either an A or a B, right? It's the length of one of the sides here. It's not C. So we can call that whatever we want to. We could say that it's A, for example. So if the length of that side is A, then this has to be B, and then this has to be C, the hypotenuse. So let's write the Pythagorean theorem out. A squared plus B squared equals C squared. And if A is our unknown, and we know what B is, and we know what C is, then we have an equation that we can easily solve. First of all, let's simplify it a little bit. 8 squared, of course, is 64. So A squared plus 64 equals 17 squared, 289. Okay. So let's start solving this equation for a squared. I'm going to subtract 64. So a squared equals 289 minus 64, 225. So if a squared equals 225, that must mean that a is the square root of 225, which is 15. So A is 15. Now, considering how this is coming right on the heels of the solving quadratic equations objective, ordinarily, if you solve an equation that has a squared unknown in it, you would have to do a plus or minus. But obviously, it doesn't make any sense to have a negative length of a triangle. So whenever we're doing the Pythagorean theorem, we don't worry about the plus or minus. Okay, let's look at number 9 now. What is the length of the missing side in the right triangle below? We're given the length of one side, 7.2, the length of another side, 5.4, and the unknown length is C. Okay, it's the hypotenuse. It's the longest side. It's the side across from the right angle. So let's write the Pythagorean theorem again, except this time we know that A, let's say A is 5.4 and B is 7.2, although it doesn't matter, we could flip-flop those. Let's see, 5.4 squared plus 7.2 squared equals C squared. Let's simplify this again. 5.4 squared is 29.16. 7.2 squared is 51.84. Let's add these together. 81. Ooh, I like that. That's a nice, pretty number. 81 equals C squared. So hopefully you can do this in your head. If 81 is C squared, then 9 is what C is, right? And if you don't believe me, just take the square root of 81. Oops. 9. Okay? So the length of the missing side is 9. Just like over here, the length of the missing side was 15. Okay. Let's look at the last question on this objective. Could 29, 21, and 20 be the lengths of a right triangle? The lengths of the sides of a right triangle. So what this question is asking is, are these three numbers do they satisfy the Pythagorean theorem? Right? Can I stick in 29, 21, and 20 into A, B, and C to make that equation true? If the equation is true, then these three numbers could form the lengths of a right triangle. But the key is, what's A, what's B, and what's C? Well, looking at these numbers, A and B are, you could flip-flop those. You could interchange them. It doesn't matter what you call A and what you call B. What does matter is what you call C, because C has to be the biggest number. It has to be the biggest number. So 29 has to be C, and then 21 and 20 could be A or B. Let's just say that A is 21 and B is 20. Now, let's plug these into the Pythagorean theorem and see if we get a true equation. Okay, so 21 squared plus 20 squared, is that equal to 29 squared? Well, 21 squared plus 20 squared equals 841. Now, is this equal to 29 squared? Why, yes it is. So, the equation is true, which means that yes, these three numbers could form the lengths of a right triangle. Okay, so that is it for this objective.